Mach meter. Mach meter gives Mach number, which is with the help of dynamic pressure and static pressure and their division. Now Mach number formula is equal to true airspeed by local speed of sound. True airspeed is a direct value, but local speed of sound should be derivated. Local speed of sound is equal to 39 root K. K is nothing but temperature in Kelvin. Actually, why we need to know Mach number? Mach number gives the indication about the speed of the aircraft. If we are going in a higher speed, then that higher speed is dangerous to aircraft. So we need to know the Mach number just to know the speed of the aircraft. Now how this Mach number helps? Let us find out. While we are cruising at higher speed of an aircraft, if the aircraft is cruising with higher speed, the flow reaches to the speed of sound, which is way too higher. And this may cause shock wave. If we reach to the speed of sound, our aircraft may experience a shock wave. This shock wave, when we are experiencing a shock wave, then the Mach number would be high. That Mach number is noted as critical Mach number, denoted by M crit. Now, when the Mach number is going to become critical Mach number, if Mach number is greater than 1, then it is noted as critical Mach number. In ISA conditions, we have local speed of sound, and that is speed of sound at ISA is either 661 knots or 340 meter per second. We only have BIP error, blockage, instrument and position error. This is important. Speed of sound in ISA conditions, at ISA conditions, 661 knots or 340 meter per second. Now we have different conditions to calculate the Mach number. The first condition is if the aircraft at ISA, if the aircraft is cruising and we are making indicated airspeed as constant and we are climbing. The aircraft is climbing with indicated airspeed constant. That means if we are climbing, the altitude is increasing. If altitude increases, temperature decreases, and also local speed of sound also decreases. If local speed of sound decreases, Mach number increases till a certain altitude. After reaching a higher altitude, after reaching certain altitude, then we would keep Mach number as constant instead of indicated airspeed. Instead of indicated airspeed, Mach number is kept constant. Now during this condition, if we are climbing, we should start at lower altitude VMO to higher altitude MMO. If we are descending, we should start from higher altitude MMO to lower altitude VMO. Okay, after certain altitude, the temperature, local speed of sound and true airspeed, everything becomes low, and then they become constant. At this point, if we start climbing, then Mach number is said to be constant and ISA increases. So with this, what we got to know, if Mach number is constant, ISA increases. IAS increases, indicated airspeed increases. If indicated airspeed is constant, Mach number increases. If one of them is constant, the other one would be increasing. And this happens during climb itself. What if we are descending? If we descend, true airspeed is kept constant, Mach number reduces, and it is also constant after certain period of time. But if aircraft is at pressure altitude and indicated airspeed is constant and we are climbing, then Mach number is independent of local speed of sound and temperature. If the aircraft is at pressure altitude, we are having the same scenario like in the first scenario, indicated airspeed constant and climbing. Here also indicated airspeed constant and climbing. Here Mach number increases, but due to pressure altitude, here Mach number is independent of local speed of sound and temperature. Okay, got it. Okay, thank you.